In this question, what we've got is a man who's investing $1,500 in a fund, and he does that every year, and he gets 10.5% interest. So if you have a look, what the first part of the question wants us just to work out what his interest was for the first year. So we have to use compound interest because it's compounded for the first year. So 1,500, 1 plus the 10.5 over 100, because that's your percentage. It's only the 1 year, so it's the power of 1, so one term. Gives us $1,657.50. We subtract the 1,500 there, and that's how much interest he's going to earn on 10.5% interest for the first year. Now, what about if he wants to do that every year for 20 years? So let's have a look and set up a pattern. So the first amount would be 1,500, and it's 1.105. So that's the 10.5%. 1 plus the 10.5% as we had in the previous part, it comes to 1.105. So that's the amount he earns after 1 year. That was that was part A. So that's the same calculation for part A there. So at the end of the first year, he has that amount, and then he adds another 1,500. He invests another 1,500 at the start of the second year. So that money there has that amount of interest applied again. So the 10.5% interest for the second year. Now we don't want to calculate it out. That would start to make it really hard in this case. So what we do is just set up our pattern. We expand that bracket and put the 1,500 times 1.105 squared, 1,500 times 1.105. So you can see that's just expanded that bracket, and we've got that amount. So the end of the third year, at the start of the third year, he's got what he had left at the end of the second year, and he's added another $1,500 to his account, and it gains the interest, and we end up with this pattern here. Now, how many terms in the pattern you start to go before you go to the end is up to you. I like to go 3, only because I just start to see the pattern nicely, and I can see that 3 years, that first amount's got the 3, then the second amount's got the 2, and the third amount's got the 1. And so I'm pretty confident to go, okay, after 20 years now, what's the pattern going to look like? So after 20 years, that first amount's been calculated for 20 years. The second amount's had interest applied for 19 years. Up until the 20th amount, which has had only 1 year's interest applied. So it's up to you. You can do two if you like, or you could do 4. I generally do 3. So just depends on how confident I am with the question. The more confident I am, probably the less terms I do. But again, you've got to be confident to make sure you do that. Don't take shortcuts if you don't need to, because it can get pretty difficult. So with this question, now what I'm going to do is rearrange my terms as I did before. So I'm going to just take the smaller ones down the front, just so I can see my geometric progression. And this is what you've got to do all the time. Set up a geometric progression. Factorize the 1,500 out, and then I've got my terms there. I can see it's a nice geometric progression of A being the 1.105. It's got a common ratio of 1.105, and there's 20 terms because I made 20 investments. So apply the geometric progression formula, some of the geometric progression formula, and then do the calculation. That 1,500 each year for 20 years comes out at $100,495.56. If we look at the next question, similar again, but it's just some subtleties applied here. So Egon's daughter, born on the 1st of January, and that day puts a trust account of $250, and then each year on his birthday deposits $250 in the trust account. Continues to do this up until her 17th birthday, and when she turns 18, collected the total amount including the interest and presented it to her. Now, what we've got to pay attention that the account's paid 6% interest per annum, but it's compounded every 6 months. So he's only depositing yearly, but the interest is being calculated every 6 months. So this is where someone who uses the formula will more than likely get it wrong, because you're not getting the subtleties. You're not going to pick up the correct amount of investments and the correct amount of terms, because the number of investments and the number of terms are different. A lot of times they're the same, and that's where formulas are okay. This one's not. So the first deposit of 250, after 18 years it should be worth $724.57. Let's have a look. Why is that the case? Our principal is always 250. Our rate of interest is 6% per annum, which is 3% per month. So we've just divided it by 2. And the number of terms overall are going to be 36. Okay, because it gets compounded twice a year for 18 years. So that's 2 times the 18 gives us the 36. There's 36 times it's going to be compounded. So the 250 outside of 1 plus 0.03, which is the 3%, to the power of 36 gives us that $724.57. The key here is not necessarily in the formula, it's making sure we understand how many terms we have. It's not 18 terms, it's been compounded for 36 terms. So, and then how much is the total going to be worth at the end of the 18 years? So if we have a look at the formula, and the computer's going a little bit slow. So we have a look here. We'll skip the page. We go back one. So again, we're going to set up a pattern. So that first amount, $250, gets invested there. In the first term, it gets invested for It's invested for 1 year, but it's 2 terms. So that we got that first amount compounded twice. So at the end of the first year, that's what it's worth. Start of the second year, we invest another $250, and then we compound it twice for the year. So notice this time it's just not multiplied by the 1.03, but 1.03 squared. This is the real trick to this question. So it's compounded twice there. We expand out our bracket to get that nice form because we want to see the pattern occurring. So again, the start of the third year, $250 is invested and compounded, and the whole amount that we've had and now invested is compounded twice. So expand our brackets out nicely. So there's what it looks like after 3 years. So after 18 years though, this is what the pattern's going to start looking like. The 250, that's our original, that's the amount from part 1. So that's what the first amount comes to, so to the power of 36. After the one that was invested on his first birthday has 17 years, so it's going to be compounded 34 times. The amount from her second birthday compounded 32 times, and then the amount from her 17th birthday has been compounded only twice because it's only been in there for a year. So again, rearrange our terms, take out the 250, put it from the lowest to highest. You could keep it that way if you like. You can still see that's a geometric progression. It's just one of the things I like to do when I do these questions. But then I see my geometric progression of 1.03 squared as my first term. The rate of terms is rate for this geometric progression is 1.03 squared. Be careful here because the number of terms we have is only 18. So because we're going up to 4, 6, 8 to 36, there's only 18 terms. A lot of students make the mistake of just looking at that last number and going, that's my number of terms. So I'd see errors in that people will put 36 terms in there. Be really careful. Know how many terms you've actually got. So it's 18 investments, so that's how many terms we've actually got here. So it's the end's going to be 18. So be really careful, and there's really simple subtleties that you've got to look for in these questions. So again, now we've got this is to apply the sum of a geometric progression formula, and there's lots of going on in there, but throw it into the calculator. There's there's r to the power of n, and r to the power r minus 1 on the bottom, and that $250 each year comes out to $8,267.17.